Hi everyone, and welcome to another edition of the Modern Community Office Hours. Here with me, your host, Tim Spick, and my colleague, Sam Snyder. Hi. So, as always, we're going to take you through some of the things that are new this week in particular. And after that, we're going to jump into a somewhat of a larger topic. For this week, the topic is reading your microservice landscape, which is based on an old blog of mine, which is based on an old blog coming from Twitter, where we're just looking at various ways that you might have accumulated things that you might want to get rid of with some automation. And of course, we're in a perfect position here to help you out there. So that's what we're going to dive into. But first, I'll take you through some of the things that are new specifically this week. For that, as always, I'm going to take you through a couple of tabs. And the very first thing that is new is that we did a release this afternoon. So if you haven't seen it yet, you can get the very latest versions of all the Open Rewrite recipe modules, plus updates to the Maven and Gradle plugins through our Rewrite Recipe Bomb. So go check it out. The 2.11 is released there. And there's quite some neat things in there. We've had a lot of first-time contributors adding to the project, which is very neat to see. And in particular, we saw that on the Rewrite Spring project, where every commit that has been added in the past couple of weeks has been from a new contributor. So we now have a explicit migration to Spring Framework 6, which was added by Patifa, Patrick Ivarsson. He works, I think, in Sweden, if I saw correctly. And he just made an explicit migration there, even though the Spring Boot 3 migration recipes already got used part of the way there. But now, if you were still using some outdated assert methods, you can get those migrated. And as well, some minor fixes to the property migrations that we do there. So very neat to see those folks contributing to the project who are new, who are migrating and finding that we missed a step or two, and they come fill in the book gaps that we have. So very pleased with that. And then, as always, we do a full write-up of everything, all the new recipes that are in this release, and any recipes that were maybe removed or renamed. And you can see all of that on the changelog that we have at docs.moderne.io. And in particular, there's two that you might stumble across for that were renamed. So the change dependency group ID and artifact ID, that turned out to be a duplicate. So we just there was one called change dependency. So if you that can't be found, then let us know. And then three others, they turned out to be the Java version 11, Java version 17, and Java version 21. Those turned out to be no more than just a redirect to an existing recipe. So we've removed that indirection such that you no longer have to worry about having these. And also in the search results that we get, if you search for a particular recipe, you won't have to skip over these anymore. So that's helpful. And then, those smaller changes, some added options, all of it described here on the changelog / 8.25.0 release page. So go check it out. And then there's some neat things that were specifically added to the build plugins. So, of course, with Moderne, we already showed you how much time is saved with every recipe run. But that was helpfully contributed also to the open source plugin. So if you now do a recipe run with those new plugin versions, you will get a printout of exactly how much time you saved running recipes. So that's going to be a neat addition. And we've also addressed a small pain point where if you misspelled the name or the package name of the recipe that you want to run, before we just tell you, well, this recipe can't be found because indeed the exact recipe could not be found. Well, now what we're going to do is we're going to show you the closest match that there is. So if you maybe mistyped something or you are using an incorrect package, we're going to be able to give you just the closest match such that you're going to be better able to solve those issues, because it came up once in a while on our support channels. Even internally, colleagues and I myself also have stumbled across just this small hindrance in finding the exact right recipe that you want. So now that we have a small option there to help you out, I think you're going to find that things are just slightly easier to work with. And then, of course, last week we told you that we've added data table support to the Maven plugin through a community contribution. And we've now written up documentation for that. So if you want to know exactly how that new option works to export data tables for the Maven plugin, go to this page, running recipes/data tables on the the Open Rewrite docs, and we can tell you exactly what you can now expect. So if you want to find out which vulnerabilities are in your individual projects, you can find those through this data table export. And of course, beyond that, if you want to see that across the entire organization, we have the Moderne platform to help you there to show you this result, but then aggregate it across hundreds or thousands of projects that you might have. So go check it out, such that you can now start to build your own recipes, validate them through the open source plugin, and from there build whatever the export you might want to see. Also new in this release is that we added recipes for Jackson specifically, so the serialization library that you might know and love. And that should be here on the Java Jackson, such that if you are still using the very old version of Jackson that was on Codehouse and package names and dependency names, then we now have a recipe to migrate that for you. So that is composed of a lot of smaller steps, where we typically replace everything, as you know, through recipes that we've tried and tested already, but now helpfully grouped together such that you can do this migration automatically through Open Rewrite and Moderne. That's really neat. We're glad to have added that to our recipe catalog, such that if you still come across it somewhere, you're now able to automatically get there without any manual work involved. So that's it for the release. Then apart from that, we have a new blog that's out on 4 ways that we can help you with hardening against security vulnerabilities and weaknesses. So we're going to share the link with you in the chat as well, so that you can have a look there. And in short, it's approaches that you know from what we can do already, but it's helpful to see them all grouped together in this way. So you can do an in-depth analysis of any endpoints that you might have that might expose things that you wouldn't want. We can help prevent issues through the static code analysis recipes that we have. We can do software composition analysis to tell you exactly what versions of dependencies and transitive dependencies and plugins you're using and what issues might be lurking in there. And then beyond that, if you want to migrate away from some of those versions, then we can help you out by automating those migrations for third-party libraries and frameworks. So it's really a nice write-up of all the things in which we can do to help you be more secure in the software that you develop. So go have a read and let us know what you think. So beyond that, we have a few more links that I'm going to share. First up is this one, where there's a nice post that we did on LinkedIn. So for mass scale development refactoring, which I recommend you go read. And this way, it's easier also to share with folks if you want that are maybe not familiar with what we can do with Open Rewrite and Moderne, and then get them on board to maybe be able to get more leverage to start using these tools at work as well. So have a look at that one. I'll share the link in chat here again. And then if you hadn't seen it yet, there's also a new podcast on Spotify on how Open Rewrite exactly happened. And you can, I'll share the link again, where you can have a listen on just an hour-long description of how everything came about and where we stand now and where we are going to next. And so then beyond that, next week, of course, there's the JCon conference in Cologne in Germany, where I'll be giving a workshop on the Monday and a talk on the Wednesday. And then after that, we'll be at Spring IO at the end of this month to give a presentation, and we'll have a booth. So if you want to come meet us, then that's the perfect place to do it. And then I know, Sam, you're also giving a webinar on the 31st of May.
That's right. We're going to be covering recipe authoring fundamentals, starting from the basics to some more advanced techniques. Regular watchers or listeners of these community office hours will likely already be familiar with much of what I'm talking about, but you may come and pick up a few new tips and tricks. And certainly, if you know someone who is interested in getting into recipe development who had not watched our entire back catalog of community office hours or other video materials, this will be a great introduction for anyone looking to get into open rewrite recipe authoring or who has maybe gotten started and is looking to take their skills to the next level.
Yes, perfect. Thanks. So, yeah, look forward to that. And then that's it for the updates that we have this week. So I'm going to stop sharing on this particular group of tabs. And then beyond that, I'm going to take you through a somewhat new topic that I'll present about next week. And for that, I'm going to share a different set of tabs. And that is this one. And then first thing you're going to notice is that this is something on a very different topic. That is because not many folks will know that I spent the first 10 years of my working life working in bioinformatics. And I thought it'd be fun to just kind of grasp back into what I did and learned in that period of my life and how I took that into my working day now. And some of the patterns that maybe carry over in the way I look at software and how things evolve and how I think we should be treating that as we are moving through automations to get things moving away from accidental drift into intentional changes.
Tim, are you about to tell me you've created a recipe that's going to refactor my DNA?
That's not me, but we have folks who are able to do this very specifically with some recent advances in bioinformatics. It's almost a shame not to be in the field right now with all the cool things that are going on over there. You want to go read up on CRISPR-Cas or some of the things that are being done in that particular field, or the protein structure prediction that is just a solved problem now, whereas they thought we would never get through it. It's all very neat what's going on over there. But I'm having fun in my job right now, so that's also good. Well, what you're looking at this slide in particular really is a multiple sequence alignment, which is something that we do a lot in bioinformatics, where we want to see what a DNA strand or a protein is made up of. So we can only, of course, see the current state, but we can determine through experiments what it is composed of, and from there do deductions and do reasoning. And one of the things you often do in the field is you determine the exact composition of a DNA sample from, for instance, a rat or a mouse or a human or an ape or something. And you line that up with a similar structure or determined from a different species. And if you put them all underneath each other, you can start to see certain patterns where you can see that no matter which species the sample is coming from, some of these things never change, or at least we don't see them in our experiments. And that is a conserved position. And then from that, you can kind of deduce that with DNA and proteins, mutations often happen and they're random, but none of them ended up in such a way that we were able to still see them up as healthy specimens in our examples experiments. So what we then learn is that any mutation at this position is probably going to be fatal. And that just leads to a big line that this is something that is important to the functioning of this protein, no matter which species you end up with. And then from there, you can start to, it really helps to line up those proteins. And then from there, you can see that sometimes things do modify, but they always modify in pairs. So in this case, you can see that the K and the E in this case, they always modify together, and the R and the D are in a different cluster. And that is typically something that then translates to the structure of the protein. where you can deduce that if you change one, then the other one needs to change as well. Otherwise, things won't fit. The protein won't fold. It won't be able to take its perform its function as necessary in the body. And that is what we then call a co-evolved position. So it tells you something about how certain elements always relate to each other, and also usually something about adaptation to a new environment. So if you see this, you can see that, well, these copies probably are closer related to each other than they are to the variant that uses the K and the E. And if you have a lot of such positions that you can analyze, you can deduce something about how closely related things are and when they branched off from each other. And that then tells you something about what was a copy of which going back all the way to the start of time. But that's something that tells us a lot. And then lastly, you also have positions where you can see that this one is highly variable. So there's doesn't really matter what kind of amino acid is present at that position, probably because it's on the outside of a protein somewhere. It's on a loop. It doesn't. A lot of variation can happen there, and you can see that a lot of it has happened over time. Whereas you can see that there's probably just as much mutations that happen to this position as happened on the conserved position. But all the variants that evolved, mutated at the conserved position, they never made it. So this shows you something about how much drift there is in parts that are not necessarily important, but they do tell you something about what help you deduce the spread of how old copies have diverged from each other. So we have all of these three. The things that never change, because your project won't make it. Things that always change in pairs. So something that tells you something about adaptation and how that might change the function of a particular strand. And things that are highly variable, but they don't particularly seem to have much effect on any particular fit or necessary changes that need to happen there. So that is roughly what I did for 10 years. I spent a lot of time looking at these types of patterns where you look at, well, we can only observe the current state, but we can deduce a lot from it if you have a lot of these sequences below each line up in this way. And from there, start to do experiments, build hypotheses and try to prove them or reject them. So that's been a lot of fun. But of course, I didn't stay in the bioinformatics field. I eventually switched to software engineering, but I still had this frame of thinking in my mind when I walked into my first consultancy gig, which was, funnily enough, looking at not one project in particular, but looking at some 30, 40 microservices, all of which were, again, copies of one another, just as these DNA and protein sequences are copies of each other. And I could only observe the current state. Of course, we had Git, but you don't want to do Git operations across 40 repositories to explore their interrelationships. But I could deduce from seeing exactly what is there, which projects were copies of which other projects, roughly at what point they branched off from each other, because I could see that some changes made it into all downstream copies of your service, but not in the original projects they branched off from. And in that way, kind of do the same type of pattern analysis to see, well, if something never changed, it's probably because it was important. So things like your deployment descriptors are unlikely to change significantly because you just have your one deployment platform. The same for your CI pipelines. It's unlikely that someone will do an experiment with a wildly different CI platform and have that be a project that gets to production. So those are the strongly conserved elements of any copy of your project that you can kind of see, well, you need at least this to be able to run this project and get it to production. And then, of course, there's also some things that change in pairs. So if you have a couple of services and then a quarter of them talk to maybe MongoDB or a different data store of a different type, you will see some things change in pairs. So some of their properties and their dependencies, they will typically change significantly, always in pairs to a different driver, a different set of connection properties, passwords, and hooking those up to their deployments and productions in the various fields. All of that is something that you could see kind of which was a copy of which going forward and across time as well. And then beyond that, there's a lot of things that change heavily between projects. One of those is typically the web endpoints that you expose, because every copy of a service you do, no matter the shared structure that you have, your endpoints are going to be highly different because your service will be doing something different. So while you'll have your shared health endpoints or your liveness and readiness and all of that, you will also have endpoints that are very specific to retrieving either users or accounts or anything that is just what that service was made to do. So using that same knowledge that I had of inferring the how these projects evolved, you could also start to see the things that maybe were introduced at a certain point in time that you maybe wasn't intended to be changed. So while, for instance, we had 40 services at my first consulting job, you could exactly see at which point they started to migrate from JUnit 4 to JUnit 5, because suddenly all the copies downstream of that initial project where they experimented with the new version of JUnit, you could see that they all newer projects were on the newer version, whereas all older projects never had those updates to a newer version of the JUnit 5. Because it's not something that is worth a lot to do if it's going to take considerable amount of effort. But on a new project, when you, again, copy paste the service that you have, throw away the endpoints and keep the structure, but change the functioning elements of it, then you're going to maybe do some small and cheap experiments, like that upgrade of JUnit, or maybe switch to AssertJ and do some experiments in that way. So those are the things that are highly variable between services, or once they prove beneficial, you'll see that downstream copies will start to cluster in a moment before a copy was taken, and every copy that was taken from that service after. Because yeah, I'm sure Sam, you've done the same. If you copy a project to a new one, you'll take the latest copy with all the improvements that one had.
Totally.
And then,
I feel like we see something very similar going on with like infrastructure as code, where CI configuration or Docker configuration or configuration for tools that are adjacent to the code itself tends to be copied and pasted between many repositories and has a very evolutionary feel to it. So when someone copy and paste the old thing and it doesn't work quite right, they fiddle with it until it does, and then someone else copies and pastes that. So we have a lot of people coming to us saying our infrastructure as code is kind of unmanageable because we have 1,001 variations on it, and we don't know exactly what the differences are. We kind of want to standardize and get everyone using the latest best practices, because when you're copying and pasting from some old thing, old cruft that might be irrelevant comes with, just as our genomes have have evolutionary baggages and sequences of viral DNA and such mixed in.
yes, yeah, absolutely. It's not always improvements that you copy over. It's just random things that just didn't get removed from the copy because they were not necessary. But it is
Totally.
things that you want to analyze if you can at scale across those services, and then choose whichever elements you want to maintain going forward. Maybe phase out some older patterns and keep the patterns that you're happy with.
Right. At some
And
point, you may wish to intelligently design aspects of your code. Yeah.
yeah, and so what I've done is with a bit of experimentation across my 5 years in consulting. is build up a collection of tools that allows me to analyze these kind of issues and then move away from some of the outdated patterns that I could see, or to just standardize highly across different services on particular patterns that are sanctioned going forward. And for that, I identified a couple of themes that we can kind of walk through with the platform that we have and see how they might help if you have such a tool set to standardize things. And then firstly, one of the topics that I often saw copied between projects, but maybe never updated as much, is things like your build tools. So if you use Maven or you use Gradle, probably you're gonna start out originally 10, 15 years ago without any particular version of Maven or Gradle, because it's just the one version that you use for all your services. But then over time, you'll adopt newer versions of Maven and Gradle. You maybe switch to the wrappers that we have for those build tools, such that your projects aren't tied to any particular version, or are tied to a particular version, but they're not going to just run the one version that is on your CI environment. And that is the type of things that we can now very easily help maintain for you through the recipes that we have with Open Rewrite and Moderne. So if you want to upgrade your Maven wrappers, then we have recipes for that. It's under core or cleanup. Wrapper. So we have recipes specifically to help you introduce the Maven wrapper if it's not already there, or to update you to the latest versions. And of course, we also have the exact same for Gradle. So if you want to upgrade your Gradle wrappers or analyze the versions that you're using, we have recipes to help you there. And you might know these from that I point them out once in a while when you go to the Dev Center that we have. And I can pull up a different one for, let's say, Open Rewrite, where we can analyze the versions of the Gradle wrappers that we have across all of these repositories and show you exactly where they stand, and maybe make an update to some of the projects if they aren't on the latest version yet. So that is something that is just a very neat recipe that we run frequently to make it such that we never fall behind again. Because if you only ever upgrade your wrapper versions when you make a new copy of your project, then you're going to end up with a wide variety of versions. And typically, that's something that we often see when we see customers use our tooling for the first time, that they do this visualization of what versions are out there, and then they see a wild spread, and just something that you ideally want to move away from, because you get a lot quicker builds when you use the latest versions.
Yeah, and it can be a real maintenance headache to have multiple versions of your tools kicking around that have different compatibility matrices, because different versions of Gradle support building on different versions of Java. So you might find like, oh, I want to upgrade, to Spring Boot 3. Well, I need Java 17. Well, I need a version of Gradle that's new enough to run on Java 17. And you can find that an apparently unrelated migration effort or response to a security vulnerability, the old version of the build tool or infrastructure that had just been chugging along happily for quite a while, suddenly becomes an urgent problem.
Yeah, absolutely. And that's what you want to prevent by heavily standardizing and being on those latest versions where you can. And luckily with this, we have the tools to give you that insight and to actually make it actionable if you want to move away to the latest versions there. So have a look at those specifically for the build tools that we have. So it can be introducing those wrappers, it can be upgrading those wrappers. But there's also small things that I've done in the past where we had some anti-patterns, where we did a Maven clean install for every build that we did in CI. And anyone that knows Maven more than just getting started probably knows that you should instead use Maven verify and not run the clean, because your builds will be a lot quicker if you don't do that local installation, which you rarely need unless you're doing a library. And that just is in general going to help your build speed up by reusing the cache that might already be there. So I've done in this way across all those repositories cleanups where you just replace Maven clean install with a simpler Maven verify and get significant speed ups just by doing that. So that's also something that you might want to do. And of course, if you've been in the field a bit longer, you'll also probably remember that initially you were able to use Maven and Gradle repositories that did not use HTTPS, but just a simple HTTP. And it's those types of changes that have become where it's no longer allowed to use those in the later versions of Maven and Gradle. So if you're updating from older versions of those wrappers, you might find that those are no longer allowed and you need to make changes there. And of course, it is a very simple change from HTTP to HTTPS, but it is something that you want to automate when you have a lot of projects.
Absolutely.
And we also saw it with JCenter, which was a very common repository for some dependencies, and it just stopped working. And then you have to make changes at scale across repositories to actually get you moving there. So that's build tools. That's one topic that we have a lot to help you out with there. And then the next thing that we often see as a copy of a copy of a copy of a copy of a copy in across different services is anything related to CI environments. So if you want to build your project in a larger organization, typically these are hard requirements that you build it with a particular tool, be it Jenkins or GitLab CI or whatever you're using. Probably you'll have some workflow descriptors there, which have slightly changed over time, but probably not changed a lot. But there are constant small improvements that get done to these files. And those improvements are, again, something that you probably don't go back in time to apply across all those projects, but it is worthwhile doing so. And that can be things like changing from the master branch to the main branch for your build. It's a small change on the phases of it per project. But if you have a lot of repositories and you want to do that change to actually adopt that consistently, then it really helps to have some automation help you out there. So to change those CI files, to change the base branch, to do maybe any deployments descriptors which expect a certain branch, all of that to just be able to automate those code changes, it really helps to have some flexible recipes to help you there. And one particular favorite of mine these days is the one where you can merge YAML, where you just take a YAML snippet and a place where you want to insert this, and then it will figure out the changes needed to actually insert the snippet that you want into that exact location where you match. This is something that you can very helpfully use whenever you want to do things like making sure that all your projects run on the same runner, or have a certain tag available when they run for your deployments, or you want to add some particular scanners to your workflow files across all those projects. That's something that you maybe tried on a single project, it worked well, now you want it on 40 projects. That's where this base recipe comes in to do a lot of that heavy lifting for you.
Yeah, this is a really common and really powerful building block that's used all the time in manipulating infrastructure as code type files, and this is really powerful when paired with using like find source files as a precondition. So you can make a recipe that merges some YAML snippet into just a particular YAML file, since by default, like any other recipe, this guy on its own is going to apply to every YAML file that meets its criteria. So the combination of using find files as a precondition with merge YAML can get you a fair distance. Just those two tools together in terms of wrangling your mini YAML files into compliance with whatever effort you're working on.
Yes, absolutely. So this is a very flexible combination that you can use. And we've seen that used to great effect for a lot of these migrations. And what we've also done is that we have used this combination and bundled them up into recipes that you can now apply just as a pre-built one. So one that I did recently for Gradle is that they had renamed some of their GitHub actions. So if you were using the Gradle/wrapper validation action or the Gradle/Gradle build action, then they now want you to switch that to using the Gradle actions wrapper validation or the Gradle actions setup Gradle. Now this, of course, it's again a very simple change to make. But if you have a lot of projects, then it's not going to be something that you're going to have fun doing that replacement. So what I did is I did exactly that. I took that precondition and I took that merge YAML, and we made it such that we can do these types of migrations easily now across a lot of projects. And I even we reached out to the folks at Gradle themselves to tell them that we now have these recipes, and we saw them actually start to make commits to their own repositories using this recipe to help their projects migrate. You can see here, this one did not work, but there were a couple earlier ones where you can see that they're analyzing their Gradle wrappers, maybe looking to upgrade those. And then from an example here, we have a commit, I think. I know one of these at least worked. It's troublesome to find the exact one that they use, but they had some 50 cases where they wanted to move away from this particular outdated GitHub actions and are now able to do so at scale through this platform. And then beyond that, we have some more examples of things that you might want to automate in your CI pipelines. And of course, this works all the same if you don't use GitHub Actions, but you use GitLab CI. Exact same merge YAML recipe will help you migrate away from all dependents to what you want to use instead. So then next up, so we've looked at build tools, we've looked at CI pipelines. One other aspect that I often saw copy-pasted a lot, typically because folks didn't quite know what they needed, is Kubernetes deployment descriptors. So this is something that you find your first project, you deploy it successfully to production, and then from that point on, that becomes your reference implementation of getting anything to production. And you copy that from project to project to project. And maybe you'll even copy some things that you don't need in every service. Things like exposing your endpoints when it's an internal service. That's something that you don't want to do. But again, having the flexibility of a platform that allows you to search across your repositories and to find particular use cases of how things are wired together, you're able to find things that you might want to update now that you've seen things at a larger scale. So what I've done with this in the past is maybe tweak some environment variables across the various images and services as they were deployed. I've used this to switch from Docker files to layered Docker images through the build packs, and then update your deployment descriptors to match that new image. Also, a thing that we did in the past is to move from a single health endpoint to separate liveness and readiness endpoints, such that you can actually differentiate between those two when your service starts to get traffic versus when it is up and running and should not be killed anytime soon. And those, again, are things that are very helpful to have applied consistently across your services, such that you never have to keep in mind, did this one use a health endpoint or did this one use a liveness and readiness group? So if things are standardized in this way, you can do improvements that then benefit all of these projects at the same time. And some of those improvements were on, for instance, resource use. If you are very standardized here and you know exactly that what you need, you can also start to scale those down and get considerable savings just by being so standardized and having the tools to be able to apply that easily and do experiments with that. And of course, you can do things like adding a graceful shutdown or updating to new versions of the Kubernetes API. by moving away from some of the beta APIs that they had to the later versions. So again, an area where there's a lot of drift that we see between various projects. That is easy now to move away from with these recipes. And so next up, these ones you probably know by now. If you've been watching the show at all, you know that I'm a big fan of moving you from between different versions of libraries, frameworks, and language versions. And of course, that is something that you see a lot of experimentation with. When you have a lot of services, eventually folks are going to diverge from what you were using in the past and going to pick up something new. And that is exactly what we now allow you to standardize on broadly by bringing along all those other projects as well onto those latest versions of libraries and frameworks and even Java versions. So if you want to move to Assert J, or you want to migrate to Java 21, or you want to adopt all the latest versions of Spring Boot, including best practices and getting you onto virtual threads, then that is something that is just very easy to do now with these standardization recipes to help you adopt all of that. So, and then lastly, there's a lot of small things that you maybe come across when you are starting to explore a lot of these repositories that you might want to immediately fix them, not once, but fix them 100-fold. So what I've seen in the past is that, for instance, you'll have colleagues who accidentally commit some DS store files from their MacBooks onto their Git repositories and share them with their colleagues. That's very much a pattern that you want to avoid. And that, of course, you can, with these automations, very easily remedy by removing those files and then simultaneously updating your Git ignore files by standardizing those across your repositories, making sure that such issues don't make it back in again. And
I think you touch on a really kind of important point about the power of automation here, in that when you have an anti-pattern, right, something that is problematic but might not immediately threaten the health of the overall organism, but might reduce its fitness down the line, if we're going back to our bioinformatics and evolution metaphor, that you might fix all of the instances that you know of the anti-pattern in your code base today, and go through some grueling effort and finally, dust off your hands, pat yourself on the back, satisfied that you have banished the hated anti-pattern. And then tomorrow, some well-intentioned developer who doesn't know about that anti-pattern and its negative consequences goes and pastes it right back in from the Stack Overflow question, or GitHub Copilot suggests it, or they invent it themselves, and you're right back to having another instance of that problem in your code base. But if you can encode that the resolution of that anti-pattern into a recipe, you can run that on an ongoing basis and be confident in a way you never could before, not only that you can prove the absence of something problematic in an ongoing way and remediate it if it does pop back in.
Yeah, absolutely. And that's another excuse for me to show my favorite blog, is that we can, not only are we able to help you automate this away once, you're also then able to start enforcing it going forward. You can do that in a gentle manner. You don't have to do a hard break on CI, but just have that feedback loop such that you only fix things once, and going forward, you'll never have to see them again. So that is something that I just think is just the perfect complement to doing these cleanups and doing them on a repeated schedule, or as part of every PR review that you do. So yeah, it's something that I think is very valuable to go over these various topics across all of your services, and just move away from the things that you're not as happy with, such that you're going to be very intentional about the way that services differ between each other, and all the unintentional differences you can actually move away and standardize, such that it becomes easier to make those changes at scale going forward. And if there's then any small improvements that you can do that suddenly you can roll out to all those services at the same time, that really starts to multiply the output of any engineering efforts that you put into this. And that brings me to, like I said, my old blog was based on an even older blog, and that's for me the original blog there is this one, and I'll share it in the chat here as well. This one really shaped for me how I've come to see engineering at larger organizations. So if you've never read this one, there's also a video option, which is I think 15-20 minutes long. And what it goes into is exactly the concept that while it is very good to have experimentation, to have those random mutations between services to help them find their fit, you'll also at some point want to standardize such that you can more easily reason across different services and do improvements and across that then affect all of those projects at the same time.
At some point, your experiment is complete and you've learned the lesson, and it's time to apply it.
Yes, absolutely. So you take your learnings and then either accept that you want to move in that direction and then move everything in that direction, or abandon the experiment and actually phase it out. And that is where the weeding comes in, where you allow for experimentation, but you also have a culture where you do from time to time clean things up again and rip out the experiments that you're not happy with. So that is a delicate balance to figure out like what exactly is a weed, what is something that is a undesirable change that you now want to move away from, and then standardize such that you can get the most out of any effort that you can put in to improve things for all developers at the same time by having small improvements that just you were able to scale across the services. So if you haven't read this one, go read it. It's for me, it's influenced how I've approached any consulting gig I've done before, and now at Moderne, I'm perfectly positioned to give folks the tools to do exactly this that they want to make it such that they can be more productive across a lot of services. And yeah, with that, I think we've touched upon most of what I wanted to tell you about today. So on your end, Sam, is there anything you want to share still with our viewers while we have them here?
I don't think so. I think we covered all the announcements. I do look forward to someone using Open Rewrite to manipulate DNA sequences. Just let us know if you need a specialized parser for that.
It shouldn't be hard. There's just 20 or so amino acids with some mutations.
That's easy. That's so much simpler than Java.
DNA is even less. You just have some nucleotides and some. You should be able to do something there.
Yeah, totally.
But the small and subtle differences, they can have a lot more interesting effects. So that is, I think, something interesting to experiment with.
Absolutely.
But yeah, then with that, I want to thank you all for showing up again. And as always, if you have any questions, feel free to reach out either in the chat here or ask me in our public Slack. And then next week, I'm going to be out. I'll be in Cologne presenting on this topic and giving a workshop. And Sam, I believe you'll be here hosting the next edition.
Yeah.
Don't yet know
that's
what
the
it's going to be
on. I don't know yet. We'll come up with a great and engaging topic between now and then. I have great confidence.
All good. And then with that, I want to thank you all for your attention and hope to see you again soon. Cheers.
Cheers. Bye.